Okay, to make this fair, I'm going to use the same colour dinosaur for each of my 3 experiments. 1 hot water, 1 medium water, and 1 cold water. So as expected, the hotter water dissolved the capsules quicker than the colder water. The hotter water means there was more collisions per unit time and more collisions with energy equal to or greater than the activation energy. Now the Boltzmann distribution can help to explain these experimental results. And just as a sidebar, Boltzmann came up with some verifications for the second law of thermodynamics. And essentially that's the only law of physics that we're sure is true. Everything else is open for debate, but that one. And he also basically proved the existence of atoms. Now, no one really believed his mathematics, and he's quite a fragile character, and he ended up killing himself because of people's disrespect and disregard for his science. It turned out he was completely right. Okay, so the area under each of the 3 curves is identical because the total number of particles is the same with each hatching dinosaur egg. So for the low temperature one, that took a long time, and that's because only these particles had enough energy to react. This line here is the activation energy, EA. At the hotter temperature, there's a lot more particles that have enough energy to react now. So at the hotter temperature, the area under the curve here, including this little bit. So there are many more particles with enough energy to react, so the little dinosaur hatched quicker. And finally, at 78 degrees centigrade, it was 33 seconds, 4 times faster. So I figure that the area here that represents all the particles that have enough energy to react should be about 4 times bigger, all the way down to the bottom here. So the Boltzmann distribution can explain why the dinosaur eggs hatch faster at higher temperatures. So why is it that the polyurethane dinosaurs don't dissolve in water, but the gelatin does dissolve in the water? Well, water has the capacity to make hydrogen bonds, and water can make hydrogen bonds with the polyurethane molecule. But the polyurethane molecule is incredibly long, and not enough water can go around the molecule to cause it to completely dissolve, because it's so big. I've drawn in the water molecules making hydrogen bonds with the polyurethane molecules. Now the gelatin is a different story. There's many places all circled there where hydrogen bonds can be formed, which will allow it to dissolve, and the gelatin is much shorter chains, so the water can actually start to pull apart these gelatin chains as the water molecules infiltrate these short chains. Now, dissolving is actually much more complicated than the IB chemistry goes into, to do with entropy and delta G. But anything that can make hydrogen bonds tends to dissolve in water. That's the takeaway for IB chemistry. And we're done. Well, not quite. All the kids keep saying that they want to eat one of the eggs for extra credit, but I don't want to see the proof of that the next day. Ooh. Alrighty, so let's stick some voltage through nichrome wire and alloy into the dinosaurs. Turning up the current and the voltage. I thought it'd be better than this. Oh, there we go, baby. Glowing.